I've started growing American Pawpaw plants from seed. The pawpaw, Asimina Triloba, is a really kind of tropical seeming fruit, but the plant is fully hardy, so I want to grow some here in my own garden. It's obviously not native, but that's true of a lot of garden plants. Anyway, my seeds have germinated and started to set off into growth. It'll take a few years before they grow to fruiting size, but during these early stages I noticed that pawpaw seedlings are a bit weird. Pawpaw seedlings are weird, but to explain why they're weird, first let's talk about normal. Flowering plants are divided into two broad groups, monocotyledons and dicotyledons, monocots and dicots for short. Monocots include things like grasses, palm trees, lilies, ginger and bananas, and monocots get their name from the fact that the seeds produce just one monocotyledon or seed leaf. So an onion seed, for example, initially produces just one straight thread-like leaf. Same for palm trees, same for all the others in the group. But pawpaws are not monocots, they're dicots, named for the fact that, you guessed it, they have two seed leaves. This is perhaps most obvious in the case of things like pumpkins and squashes, where the first leaves produced are just plain ovals. These are the seed leaves, the cotyledons, and the really cool thing is that these seed leaves are sort of packed away inside the dormant seed, ready to deploy, almost like they were inflatable. One of the most conspicuous examples of this is a peanut, which is a seed. In fact, it's a type of legume, a bean, hence peanut. Have you ever looked at the two halves of a peanut and thought, hey, those look a bit like leaves? Well, that's because they are leaves, or at least they will be. These two halves are the cotyledons of the peanut seed, which act as food storage for the developing plant. If we look really closely, that little bit where they were joined together contains the embryonic form of the rest of the plant. That part there is called the radicle, that will grow into the root. And in the case of peanuts, there are also the first true leaves right there, waiting in embryo form too. Of course, all of that would only happen with raw peanuts like this one, not roasted. And not actually this one, because now I've broken it in half. But if you look at a roasted peanut, you'll probably be able to see these structures inside it. So what happens with a typical generalized dicot seed, like this peanut, is something like this. The seed is buried in moist soil. Exposure to moisture and potentially a load of other factors like temperature and sometimes presence or absence of light triggers the seed to break dormancy. It wasn't ever dead, it was just resting, but now it wakes up and starts to grow. The whole seed absorbs moisture. The cotyledons start to swell and expand, breaking apart the seed coat. The radicle, the embryo root, starts to grow downwards, forming a taproot, from which other roots branch off, including very fine thread-like roots that will take up moisture and nutrients. But at this point, the whole plant is still surviving on the food that was stored in the cotyledons. With the roots now somewhat anchored in the soil, the stem starts to extend, pushing the cotyledons and apical bud up out of the soil. The cotyledons then unfold, expand, and produce chlorophyll, forming the seed leaves. And this enables the seedling to start making its own food, sugars, out of water and CO2 and sunlight. The seed leaves don't usually resemble the typical leaves the plant will later have. They're usually just simple ovals, solar panels to power this stage of growth of the seedling. The actual plant grows as the apical bud, that is the bud at the top or apex of the stem, develops and forms the true leaves. And then the plant begins to look like what it actually is. Eventually the seed leaves are no longer needed and the plant reabsorbs nutrients from them and they wither away. So that's what a normal, typical dicot does. But as I mentioned, pawpaws are a bit weird. They start off pretty normal. The cotyledons provide a food store for the developing embryo plant, but in this case it just grows a taproot, a lot of taproot, and some lateral roots and fibrous roots, but nearly all of the energy stored in the cotyledons is devoted to development of a pretty hefty taproot. This taproot swells and some of the food reserve from the cotyledons is transferred into it. And instead of the plant pushing the cotyledons up out of the soil, they just sort of stay there. Instead, the stem forms a loop, and this pushes up and out. And this goes on for several weeks. No leaves appear yet because the apical bud is still underground. Then the plant just discards the cotyledons, or what's left of them, leaving them underground. The stem snaps away from them and then straightens up, but there are no visible leaves. They are there. The apical bud is tiny, and again, over the course of weeks, it now slowly grows and develops the first true leaves. So there are never any seed leaves visible above ground. I imagine this behaviour might have arisen from an environmental selective pressure to get that taproot down as far and fast as possible, to secure a supply of water for the developing plant. So perhaps in the place where this plant developed this strategy, the water availability in the soil fluctuated annually from soaking wet to baked dry, and thus seedlings with a tendency to put up seed leaves and only put down a short taproot would often dry out and fail, whereas the seedlings that tended to prioritise the taproot development were the survivors. So that's how pawpaw seedlings are a bit weird. Nature is pretty good at this sort of adaptation and deviation from standards, so I expect there are other plants that bend the rules in perhaps other interesting ways. If you know of any of those, let me know in the comments. Thanks for watching, and I hope to see you again soon.